I'm talking to you. This is Goddess of Science Physics, and I'm Mrs. Bolvin, and today we're going to talk about natural frequency, which is part 6 of my sound series. Okay, let's get started. So the main idea of this section is when any object is composed of an elastic material, and we talked about what's elastic and what's not elastic. Elastic materials return to their original shape after they've been bent or disturbed in some way. Inelastic materials don't. Metal is a great elastic material because it will return to its regular shape. Silly putty, not so much. You squash silly putty, it's pretty much going to stay squashed. So silly putty, inelastic, metal, elastic. So these elastic materials, when they're disturbed, it vibrates at its own special set of frequencies, which together form a special sound. And a great example of this is if you drop a wrench and a baseball bat on the floor. Even if you were blindfolded, you could probably tell which one was made out of metal and which one was made out of wood, if the baseball bat were made out of wood. You hear distinctly different sounds. Because the objects vibrate differently when they strike the floor because they're made of different materials. The sounds that they make is the result of a natural frequency. So natural frequency is the frequency at which an object vibrates when it's disturbed. It just kind of naturally goes to that frequency, doesn't really have a whole lot of choice there. So it depends upon the elasticity of the object, so what it's made out of, and the shape of the object. So the natural frequency of a smaller bell is much higher than that of a big bell, and it rings at a higher pitch. The bigger bell would be kind of like a church bell. The small bell would be kind of like a small bell that you would ring if you wanted to get somebody's attention. Most things, planets, atoms, almost everything in between, have a springiness and vibrate on one or more natural frequencies. At the natural frequency, it requires just the minimum amount of energy to produce the forced vibrations to make it vibrate. So it doesn't take a lot of energy to make it vibrate at its natural frequency. The least amount of energy is required to continue this vibration.